So today we are going to talk about mobile device security models. Uh, it's all about the mobile device, especially the not actually mobility, including a laptop or something. No, it is only for mobile devices. The security of mobile devices, the smartphones that you are handling, you are using to navigate using GPS and other applications. So today is going we are going to talk about only for mobile devices. Um, First, we will introduce the security models of Google Android. Then we will talk about the features of Apple iOS. And finally, I think we will not cover these parts in this lecture, the security model and the features of Windows Phone. This is going to be introduced in the next lectures. So today we will only introduce the first item and the second item, which is talking about the Google Android and Apple iOS. So Google Android security. We have here, we have the Google Android security. We'll talk about Android security model, and we'll see what is security model generally, and the Android sandbox, the file system permissions, and we'll not talk about Android SDK. Let me remove this part because it should be removed. This part should be removed. Just give me a second. Okay, just so these parts I'm not going to introduce these parts. Okay, only four parts will be introduced: the Android security model, the Android sandbox, the file system permissions, and the Android permission model. The Android permission model. So the Android security model, first you have to think about the kernel of the security of the Android operating system. The kernel is Linux kernel. So if you know about Linux, you will understand the security of Android. If you know about Linux security, you will fully understand the Android security because it depends entirely on Linux kernel. The Android applications, they use the sandbox, as we told about sandbox before. And we know that each application is residing in its own sandbox. So this is app, and this is another app, and this is another app. These are the applications on the Android, installed on Android, and they all residing over the operating system layer. This is the operating system layer. So each application uses its own sandbox to be separated from other applications, and every one of them using their own virtual machine. That's very important to understand. Each application has its own VM. VM means virtual machine. So every application has its own virtual machine. And also, you add to this, they have their own process, means they have their own virtual machine process. So it means they are fully isolated from each other application. That's why I'm telling you, I'm asking you before, I have asked you a question and I'm repeating it here again. Do you know why the antivirus is not effective on Android? Anybody knows the answer for this? Not too effective, but it is little effective. It has low effect on securing the Android. You know, anybody knows the answer? I'm asking about the application, the antivirus.
Doctor, because it don't separate the applications.
The, yes, Ferial, they separate the application. As you said exactly, but they separate the applications, and uh, for this means for the antivirus, it means that it will be residing in its own sandbox. So this is the antivirus. It will reside on its sandbox and on its separate virtual machine, so it will not have control on the other applications. So that's why the antivirus will not be too effective when we talk about security model in Android. Um Returning to the sandbox, you have to understand that sandboxing is very important, especially if you talk about security, because no applications, especially the bad applications, no application will be in control of other applications. So if the hacker is able to install an application on your Android device, the application will not be able to control other applications. That's the reason of sandboxing. So it's important to have this sandbox because it separates the applications and separate the connection between application. So there is no control between applications. No application can control other applications. So that's why the Android sandbox assign a user ID to each Android application as an entity. So each application is an entity with its own user ID and runs the application as a separate process with its own permissions. That's why sandboxing is separating also the permissions and isolates the applications and their files, resources, devices, and memory. So the sandbox, for example, no application can control the files of other application, the resources of other application, and the devices of other application, and even memory. No application will be able to, for example, make a memory overflow. This is an attack for memory. It will not be able to make the memory overflow attack because the other applications will not be able to communicate that application. So even if the hacker is able to reach the memory of one application and crash the application, if the hacker will be able to crash the application, he will not be he this crash will not affect other applications, because if this crash happens in other operating system, if the crash happens, memory crash happens, it will affect other application. But if it happens in Android, it will not affect other applications. The only application that will be affected is the application that has memory crash. Other applications are running safely without any problem because each application has its own resources, files, and memory. That's why. The file system permissions. If you know about Linux, Linux has file system permissions, and they are using the closed policy. The closed policy means that uh, mean, for example, open policy. What is open policy? We understand open policy, then we can understand the closed policy. Open policy means I open everything, I make everything available, and I stop stop the access or deny the access for whatever I want. So by default, I open everything. Then I close only what I want to close. This is open policy. But closed policy is the opposite of open policy. Closed policy is closing everything and open only what I want to open. This is different. So Linux is a closed policy. A closed policy means it closed everything. It by default it deny the access of any file. If you want to access or have privilege on a file, you have to take permission on this file. No file is available by default. No, you have to be the owner of the file to be available to you. And if you want to access any other file, you have to take permission from the owner of that file. That's why Linux file system is very, very strict, and compared to Windows. Back time when I was in China, I traveled to China for 4 years in 2007, and at that time I was having Windows operating system. But actually, in China, they have many viruses. They have many breaches and viruses and many problems that happen to my device. To solve this problem, one of the guys there asking me to install Linux. I said I never used Linux. He said it is easy. You just get used to it, then that's it. I asked him why should I apply Linux or install Linux. He told me because Linux is a closed system, but Windows is an open system. That's the first time to hear about open and closed system. This means Linux is closing everything and open only the ports that he want to use or it want to use. And for the operating system, the Windows operating system, they open everything. They open all ports and then close the ports that they don't want. So I listened to his words, and then I really installed Linux on my device. And starting from that time, I didn't face any problem, any security problem, because they don't in China they don't use they are not familiar with Linux too much, so they don't have
Doctor, Linux is like the app.
yes, Linux, and yes, exactly. You can say Android iOS is similar to Apple. Uh, exactly, is suitable for Apple applications, but for the Android, the Linux is similar to Android devices. Okay, you can say we have three computers, one with Windows and one with Linux and the other one with app OS. Then we have three computers now, but each computer has the corresponding smartphone. For for the Windows computer, they have Windows Phone operating system. For the Linux computer, they have Android smartphone. For the app OS or the device with app OS, they have the corresponding iPhone or iOS. So this is the correspondence between smartphones and computers. But actually, they work in different ways. Android, Android only working, maybe you can say, in the same scheme or the system security model, work in the same model. The same security model is applied on Linux and Android. Because the kernel, if you know about the kernel or the core of Android is Linux. So it follows the same concepts of security, the same concepts is applied on Android. For the security of compute of memory, there is a pro police. This is some kind of you can say software, and this software is by default is enabled on Android. This pro police prevents Stack Overflow. I don't know if you hear about Stack Overflow before. Do you know what is Stack Overflow? Anybody knows about Stack Overflow? What is Stack Overflow? Nobody knows?
No.
Oh, did you take the operating system course? You hear about the Stack Overflow or microprocessors? There is a subject called microprocessors. If you study
Ah,
microprocessors or operating system, you will hear about Stack Overflow. This is a way of having a function running, especially if the function call itself many times. So if the function calling itself many times, this is called the recursive calls. Recursive. If you hear about the recursive calls. So if the function is calling itself many times, every time it registers something in the stack. The stack is a place in memory. And every time the function want to return back, she go to the function goes to the stack and it retrieve the last position in memory. So it goes to the stack and writes something, goes to the stack and writes something, and so on until the stack overflow, means it's filled. It is filled with values. It cannot handle more values. It overflows. The word overflow, like water, a glass of water, and you filled the water, and you're still pouring some water here. You are putting water here, but more water will be spilled on the ground. This is an overflow. This is the meaning of overflow. So you are adding something and you don't have a place for it. The function is adding to the stack, but the stack is full. It didn't have or doesn't have a place for more information to register. So the stack is filled. If you add in more than that, this is an overflow. The stack overflow is one of the attacks, one of the common attacks for memory. For example, if you have an application, any application, like application for the pharmacy, like application for the hospital, for the bank, any application, and you can go to inside the application as a hacker can go to the application and open the code of the application and update the code so the function write many times in the stack, and he is successful to make Stack Overflow, and the program will crash, will not work. The program will not work. So the hospital will stop because their program is not working because of a breach for the memory, which is a Stack Overflow. So this is Stack Overflow, and you please revise it. Go to operating system courses and search for Stack Overflow and understand more about that. So the Propolis do many things like protect against leaking kernel addresses, everything in the memory, or they call it leakage. Leakage means the addresses is not registered on the correct location, and also integer overflows. Integer overflows is one of the Stack Overflows actually. Integer overflow, if you know about addition, and you know that, for example, I can add or multiply many times or have a factorial of something, of some number, but sometime the value or the result will not handled, the entire result will be handled on the memory because the entire result is very huge, so it will not fit the memory. For example, if I have this is a memory, and I have this location. This is one of the locations in the memory here, and I have an integer result of multiplication, or result of factorial, and the result is like that. How can I get this big address to be here? I cannot do that. This is a place located for my application on memory, but the result is very big. I cannot handle it on the location of on the memory location. This is overflow, means this is very big play, very big data should be reserved or saved on very small place. Okay, and that's the overflow. The word overflow, you will face it many times in security, because actually, even with advanced operating system, still hackers can reach the functions and make Stack Overflow. Okay, that's the problem of memory, which is a Stack Overflow, one of the common memory attacks. The hardware-based no execute parameter control that parameter. This is Propolis doing all of this. Control the parameter that no execute to prevent code execution on the stack or heap. That's flag no execution on the stack or heap. For example, if malicious code goes to the stack or heap, it will not be detected by the operating system or security. So no execute parameter prevents such thing from happening. Also, the Propolis can encrypt data through the cryptographic application programming interface. This is one of the APIs which support crypto primitives. That's also added to the Android, and every communication or every application communication messages between applications, or even communication on the network, all the data is encrypted. Okay, and finally we will talk about, here we still have what okay, routing and unlocking devices. What is routing something? Anybody knows about that? Root. What is the root? Routing, what is the meaning of routing? Anybody knows the answer? We are 7 now, I think.
Like a cycle or circle?
Routing, cycle or circle? Circle. Do you mean what? Do you mean circuits, computer circuits, or what? Or sorry, electrical circuits? I don't know.
No, not electrical circuits. Like in a circle, routing in a circle, like a circle.
Yeah. You mean loop, right? Loop. I
Yes,
mean
doctor. Yes.
looping in an infinite loop. This is actually this is not the definition. Thank you, Hagar, and I want somebody else to try. Routing is not cycling in an infinite loop. No, but this is very good to. This is one of
Doctor,
actually this is one of of the attacks.
doctor, you mean routing like a direct destination, like the route for a target, like this, or what?
I mean, this is routing is one of the attacks. Routing means what? I mean, if I told you I'm a hacker and I have rooted a device, what does I mean? What as a hacker, you are a hacker and I'm a hacker.
Doctor, do you mean
If I'm
hack?
telling you that, what you understand? I have rooted this device. Yes. Ferial, you were talking.
Yes, doctor, do you mean hack?
Yeah, I mean hacking. Yes, all of these are hacking. Even Hagar said looping and cycling in an infinite loop. This is one of the attacks, but this is not routing. Okay. Actually, the I have written it's here. The answer is here. But if you understand this, you tell me the meaning of it. Routing, what the meaning of routing a device? Routing a device is what? Okay. Okay, let me thank you for your contribution. Thank you, Frial. Thank you, Hagar. And the routing is just if you know the operating systems, they have layers. This is the hardware level. This is the operating system level. This is application level. The lowest one is the hardware level, and the one in the middle is operating system that running the application on the hardware, and the application is installed on the operating system. Now, the operating system has higher privilege than the application. So they have more permissions compared to the application. For example, if I want to update operating system file, the application cannot update operating system file. Cannot. But the operating system had this privilege. The privileges of operating system is called root privileges. Root privileges. These root privileges, they call it root privilege. Okay? These privileges or permissions is only for the operating system. But some applications are allowed to do that, but with permission from the operating system. Actually, if the app is malicious application, it can have the privileges of the operating system without permission. If the application can have the control of the operating system, it can control on the entire device. This control is called the privileged root permissions. In summary, this means the application can control the operating system of the device because it has a root access of the device. Okay, you understand now? Hagar, you understand, Friel? Okay?
Yes, doctor.
Okay. So now you understand the root privilege. Actually, they have Android, they have a control over the root. Uh, Even Android allow user to change boot sequences. For example, the boot sequence, if you open your device, you will follow some sequence starting from reading memory and then the welcome screen and then login screen. And then finally, you'll find the desktop. This is a boot sequence. The boot sequence is one of the root. If you want to change it, you should have a root privilege. So this sequence is Android also allow for this, allow for accessing the the root privileges, but for permission, must be done with permission. And that's for the root rooting a device. One of the attacks is rooting and unlocking a device. One of the attacks, one of the common attacks, is to have a privileged permission on the device. And one of the common attacks is called, you hear about it, is denial of service attack or DOS attack or DDoS attack. Even the DDoS, they have zombies, and these zombies, the controller or the hacker has a privileged a root privilege on the zombies, so it can control the zombies and direct them to do whatever they ask them to do. If you want to control a device like a zombie, make it a zombie, you have to be a privileged root user. So, for example, if I want to control a device in Paris or in America, I can control it using the privileged permissions only if I can access its operating system and have a privileged root permission. Okay. For the Android permission model, as we said, the permission model is like two people speaking to each other. You can give your phone to your not a phone, actually. You can give money to your friend, and your friend can give you back money. You permit him to take your money, and he permits you to take his money. That's the same analogy of the applications in Android. So if you want to permission for an application, you go to the application, ask him for permission, and the application will give you permission. If another application is asking you for permission, you allow him to do that as an application. So it is sandboxing, speaking to each other. And this is restrict the permissions, and this is making mutual trust between applications. Okay, I think it is enough for today. I think it is enough for today, and I know that you this subject is containing many theoretical parts. I know that, and I'm trying, inshallah, after the vacation, I will try to have more labs with you and to make you understand more deeply the concepts of the wireless and mobile device security. And that's it for today. If you have any questions?
دكتور
Yes.
دكتور محمد حمدان عندي جامعة عادة المتر.
أيوه. Yes.
الامتحان لسه موعده على الساعة 1 مظبوط؟